Hei, am fost la DevTalks 2025 și am selectat pentru voi câteva prezentări interesante despre AI, dezvoltare software și tendințele care schimbă industria. Hai să vedem împreună ce idei merită urmărite în perioada asta. Prima prezentare pe care vreau să vă arăt este foarte practică și clară. Liam de la Microsoft a vorbit despre cum putem construi aplicații AI reale folosind GitHub Copilot în Agent Mode.
Copilot comes in with a whole bunch of solutions. So we've got the assistance of fixing errors, we've got code completion, interactive chat and agent mode, that's the best bit now, I love agent mode. You've got code explanation, so you can highlight and explain what's in your terminal, you can explain what's in your code editor, you can do a whole bunch of stuff now, it's really cool. Test generation is probably one of my favorite features. I love TDD, but I also hate it at the same time. So TDD, test-driven development, if you didn't know what that meant. I love writing tests. I hate writing tests. I absolutely hate it. I like writing and seeing my code actually work. I don't really care about the functionality of it really that much. Jokes, of course I do. I work on some of the cool tools. Inline code suggestions is one of the best bits as well. So this means that you can spend less time debugging your stuff, writing tests, summarizing changes, correcting syntax, fixing those small nuances, even writing readmes, which I'm actually going to show you what agent mode is going to be doing today shortly. But you have got to spend far less time on this stuff so that you can spend 10 times more time developing. Let's just say a developer wants to write a for loop. So what we're going to do is we open up the chat, and you'll notice down here we're in ask mode. Doesn't really say it, this is an old video, but it's still none the same. So it says, how do I write a for loop? Alright, Copilot's going to give you a whole bunch of stuff because you've given it zero context. And this is one of the best bits about these LLMs and working with Copilot and all the other wonderful models. ChatGPT is still the same as well. You need to give it all the context you possibly can, because otherwise it's going to say, here's a JavaScript, here's a TypeScript, here's some Python, here's some Java, here's some C#, and all the rest, right? It's very, very verbose. And we probably all have this issue with LLMs as they stand today. All super verbose. So then you can learn how to construct these prompts. And let's just say, how do I write a for loop in JavaScript? So what you're going to do is just start adding to this prompt and giving it more context time and time again. And I'm going to show you how you can alleviate all of this stuff very shortly, because this looks like an arduous task. Not something which I really like doing. I hate writing prompts. Prompt engineering is an actual job title now. God forbid where we're going to go in the future with this. But hey, you can see how this is starting to narrow it down a lot more and a lot better for us. So, we now have our JavaScript. But what if you want to go even further? Well, I actually forget about recursion and recursive functions. So what if I want to extend it a little bit more and say, how do I do a for loop in JavaScript to include tail recursion? It's not very nice syntax, it's not very, it's not your everyday syntax. Maybe if you're a senior dev or staff dev or whatever, you probably use this, but it's confusing, not very readable. So you can see how we've come from write a for loop to write a for loop in JavaScript with tail recursion. All right, wonderful. Do you want to be writing that final prompt every single time? No, probably not. So what we can take is we can alleviate that and start giving these LLMs metadata. We can start giving them pre-prompts. And I'm going to show you how you do that in your VS Code settings.json file very shortly. But first, let's have a little look at the evolution of AI. So who remembers when ChatGPT came on the market and was like, oh my god, bang, everybody just use AI to write everything for you, do your whole job. Yeah, we remember that. It was about 2.5, 3 years ago now. We've come super, super far. But all that was based around was just enabling your applications to become RAG. So retrieval augmented generation. So you ask it a question, natural language, it'll throw back something to you, which you think you're talking to a human, but you are very much not. It's all token and mathematics based. Then we moved into assistants, but it took a while for us to move into assistants. Now assistants are things that can do things, not very good English, is it? Tools that can do something for you, okay? So it's based on automation. It's not fully autonomous, but it kind of has an autonomous edge to it, and it can't make decisions if the human is still in the loop. And then we look at agents. We move very, very quickly from assistants to agents. Now, the agentic world is where we are today. It's kind of been around for, I'd say, about 6 to 8 months now. I remember talking back in December, January time about agents and being like, oh my god, these are the next greatest thing. And then suddenly we just moved on already to MCP. So this slide is already out of date. So what's an agent? I'm sure if you've been to many talks, you would have seen probably, I don't know, a good handful of different explanations for an agent. Everybody seems to have their own made-up definition. This is Microsoft's, this is where I'm from, this is what we call an agent, okay? So a semi-autonomous software that can be given a goal and will work to achieve that goal without you knowing in advance exactly how it's going to do that or what steps it's going to take. That final bit is probably the most scariest part for me because you have to be very careful with what it's going to do. You don't want to give it full access to your bank account. You don't want to give this agent full access to go booking tickets for you. Because hey, it might think that you're a bougie person, understand all the context, and suddenly book you a business class or first class flight. You don't want that. And I lost out my clicker. You don't want that at all. So when it comes to working with agents, you've got to be super, super careful with the context. You've got to understand what it's doing. You've got to understand where it's going and what you want it to do for you. But they're set out to accomplish three things. Reason over a provided business process. So you want it to understand and comprehend what it is that you want it to do. So it's kind of like a yin-yang situation. You're kind of telling it, you've got to give it some kind of prompt and understanding to sort of go off and do something for you. And I'll explain this with a diagram very shortly. Then it needs to retrieve the context and complete that process. What it does by completing that process is actually up to itself, whether it calls a tool for databases, whether it calls a tool for data lakes, anything like that. Get that data, retrieve it, consume it, and work with it. It then has to perform an action for the end user. Well, it doesn't have to, but more often than not, you'd want it to. Otherwise, what's the purpose of an agent, right? You want it to do something. Now, I've got some really good examples later on to show you exactly what this does and how it works. But here is a diagram. So, a user throws in some natural language. Tell me how to optimize the usage cost of my Azure subscription. And FYI, this could be any subscription or whatever AWS or GCP you use. It doesn't have to be Azure. I'm using Azure because that's what I'm from. So you give it this question. You say, how do I do this? You then have a FinOps agent, so a financial operations agent, which is going to go and do that for you. It says, here are 5 steps to optimize the cost of your Azure subscription. Okay, so it's going to go and comprehend the data. It's going to search Azure, learn documentation, Bing. How's it going to do that? With tool calling, MCP servers. It's going to go off and have a series of tool calls within that. It's then going to orchestrate using the models that it has available to it in that subscription, whether that's Olama, GPT, any of, I say Olama, but yeah, any of these models that we have. Mistral is another one it can use. And then it's going to perform that action for us. What does that mean? Well, write bicep code, write Terraform code, write an Azure function, a logic app, anything like that. It's going to go off and do that for us. It's not going to ask me to do it, it's just going to do it. That's the purpose of an agent. Another way to look at it is a LLM-based control flow. Now, what we have here is an LLM in the center. It is the core. This is not a sequential flow. It's basically going to make decisions and decide which part of the program or which part of the tool is going to call based on the data and context it's retrieved already. So it's not necessarily going to pull the paper reader if it already has references from different paper providers. It's not necessarily going to do the quality checker if it already has a quality checker and it already has a substantial amount of data which is confirmed and reliable. So you have to understand, or it needs to understand what it already has with the data, what it's consumed, and then the next step it's going to take. Like I said, this is a yin-yang. It's back and forth, depending on which tool and where it is in the process. It's completely self-deterministic at that point. Here's a good example. Over here, we have got our source control. We don't want graph open, we want changes. Well, let's get rid of that. Over here at the top, we have got a chat completion, commit message generation. What is that going to do? Well, I'm telling it to be as detailed as you can with the file changes, the reasons for the changes, add lots of emojis. Okay, so what does it look like if I take that out? If I click this button here, this is going to use Copilot to create a commit message. Hopefully it's going to be nice and boring for us. It absolutely is. Add additional configuration, documentation for project structure and coding standards. That's kind of okay, but I actually want a little bit more definition. I want to understand what's going on. So let's do that again. And this is a really quick example. If I press that, hopefully we're going to get more of a verbose commit message. Yeah, there we go. And we've got some emojis maybe somewhere scattered in there. Okay, add additional configuration, documentation files for the project setup, yada, 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 yada. Amazing. That's a brilliant commit message. I'm not going to read it all, but you can kind of understand what the meta prompting is doing at that point. I've done nothing but click the same button twice with additional meta prompt behind it. So this is what the settings.json file can do for you. You can add this in with context once you have Copilot installed. Now down here, all I'm giving is Copilot a bunch of files, the MD files, that I want it to use in context when I ask Copilot a question. Those files are the spec documentation that I've been given from my wonderful manager. It's going to say over here, here's the spec. This is an e-commerce store that will deliver both digital and physical goods. To that end, we need to track products, inventory, orders, transaction ID, customers, etc., etc. Here is the stack that we're going to be using, Express.js. We're going to use EGS, Tailwind, CSS, best practices for logging and monitoring, and a few other things scattered in there as well. Then we've got the JavaScript styling. So as you can see here, when it comes to writing the models, the data type models, we've got exactly what we want. So we're going to be using the Sequelize. We're going to have, this is how I want all of my models to look. So I'm going to open up Copilot chat over here. And as you can see down the bottom, I'm using agent mode. Because you can't see, it's just like the chat box with an agent mode drop down. You have ask, edit, and agent. We're just going to use agent. Then we've got Claude Sonnet 4, which I'm going to use. Thank you, sir. I'm glad we agree. So this is really, really good for project documentation. This is good and really quite precise when it comes to writing code elements. We're not going to really be writing any code. We're just going to get it to do a project setup. But you've got a whole bunch of different models. Oh, and FYI, you can bring your own models to Copilot too now, by the way, if you didn't know. And what I'm going to write here in this prompt is saying create the project and install the packages for the project using npm. This is going to be a JavaScript project. We have already established that by using EJS and Tailwind, etc. in the spec. Create the needed markdown files for a professional open source project. Detailed README, code of conduct, contributing guidelines, security, MIT license. Nobody likes writing that stuff, but it's all proper and you absolutely need it for an open source project. Copilot, do your job. Anything else you need is necessary. Use lots of emojis and have some fun. So this is agent mode. We're going to see if this works. If it doesn't, this is the live coding demo gone wrong, but hopefully it will work for us. What it's doing is taking in 5 references. You can see that over here. We have got the drop down. It's used everything we needed to do. Ignore the name of this folder. This is something I used again as part of a demo I used. We've noticed that it needs to do an npm init. Cool. So we've already established that we can run terminal commands. I'm going to click continue. Hopefully it'll pop up a box. There we go. It started to install these with npm. It's doing an init. So hopefully it now needs to pick out from our spec everything that it needs in terms of the packages. So it's going through, it's created that. npm installed Express, EJS, SQLite, SQLite, PG, .m, Stripe, Helmet, Morgan, blah, 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 blah. It has picked out from the spec all the packages we need from npm. We're going to click continue. Hopefully this doesn't absolutely bombard my laptop with stuff, but hey, we're going to go for it. And as we can see us working through this, it is doing so many things in the background. Here we go, we've got Jest, Node, Tailwind, because that is from the testing spec, if you remember. So click continue. All while, if I open up the sidebar, we can see in this little pane that we have started got a package log, package.json, node modules. Everything is starting to come to life a little bit. Now this is where it gets a little bit hairy because it's going to start making me create database models, it's going to start making me create folders, but we're just going to go for it for the sake of this demo. We're just going to absolutely run with it. So now we've got a database directory, which makes sense. We need DB for our schema and our test database. Maybe it'll go off and do something in that, I don't know. It's creating models. I hope it doesn't try and create some models for me because that'll be some great fun. What I really want out of this is a README. Care about that because I'm a vibe coder and this is great fun for a demo today. We've created a README. So let's go and look at this README. I'm actually going to go and pause this. We can pause agent mode, by the way. We can absolutely pause it. I'm going to close down chat for a second. I'm going to close this pane and actually let me go and open up the README and see what it looks like, just in preview. You would all probably agree if you go to GitHub and see something that looks like this, you'd think it's pretty darn professional. You'd think that's a pretty decent open source project. Project structure, configuration, how to get started, database schema, what it is, key features, testing. This is pretty darn cool, right? If I came to write this README, I would literally just put get started, npm install.i, move, go, run with it. I would never do any of this stuff, okay? Deployment. You can kind of get the point of agent mode at this point. It's done a really phenomenal job at starting out my project. Now, don't get me wrong. Agent mode is not going to solve all your problems. It's definitely not going to fix all your problems, but it's certainly going to help you and give you a great foundation to work on. Just a quick recap. Copilot, chat mode in VS Code is an AI paired programmer that will help you achieve all of these wonderful goals. Now, there's one other thing which we have, which is extensions. I mentioned this earlier. We have the @Azure extension. And by the way, you can create your own extensions too, by the way. It is really cool. So the @Azure extension is an extension to Copilot. It gives you context of what's going on in your Azure subscription. It is essentially tool calling at this point, and you can use it in 2 different forms. You can use it in agent mode, where agent mode will understand that you have this tool installed and will go off and call it for you. during that big long process. So say that README, I wanted all the subscription IDs, not that you put that there, but a great example. It would go off and call your Azure subscription, find out all of the relevant subscription IDs, and plug that in by using the extension itself. It doesn't necessarily have context without the extension, okay? It's there to support your DevOps, your software development lifecycle. It's all part of that one window, one context environment for you in VS Code. So let's look at Ask Mode, Agent Mode, just to cover this one. So Agent Modes, it determines your context. You've kind of seen it. It's multi-step purpose, and it goes off and creates a goal for you. Whereas Ask Mode is very much chat-focused communication. You can use that as you're in chat-focused mode as well. In both of these, it's just you're implementing it yourself in Ask Mode rather than Agent Mode.
Următorul speaker a vorbit despre cum AI-ul și open source-ul pot transforma produsele SaaS și business-urile tech și vă las în continuare o parte de prezentare despre AI Agents, MCP și Edge AI.
Products would be kind of augmented by agents, I assume, in the future. So it's a big deal, and it would lead to an evolution in how software as a service works. So I try to create like the most simple definition for agents, right? Maybe it can get more simple than this, but this is one that I found like super convenient and super easy. And it's just an agent uses AI to pursue goals and do tasks, right? That's it, in its core. But of course, as everything, it gets complicated. So here are just a few agent types. There can be more. These are just a baseline, let's say. So first we have the planning type of agent, right? The one that creates and manages plans to solve tasks. And this guy uses the general purpose agents to kind of do their bidding. So the general purpose is a versatile tool user. So it can call tools, it can call LLMs, it can do a lot of things, and that's the agent that's actually doing the work. But the planning is necessary. The third one is React, and I think this one is the coolest in my opinion. So how many of you have used, I don't know, Cursor, Copilot, or Windsurf in the past year? Right? Okay, everyone. So all these agents that are built behind these coding tools are using something similar, or if not the React pattern, right? So they use this to think and then to solve step by step, and we can see that in the Cursor console that it's doing some thinking. It's trying to generate that code in steps, not immediately like let's say big LLMs were doing last year. And last but not least, the software engineering agent, which does exactly what I've said before with Cursor and Windsurf. It researches and writes code, and we're super happy about it. Okay, agents components. So now we can think about an agent as in parts. What are the main components that drive the agent? So first you have the flow, right? Flow is something that describes how to solve a specific use case. Then you have memory, and here it's a very oversimplified abstraction when I say memory, because there can be like short-term memory, medium, long-term memory. There can be memory that's shared only between some agents, so it gets complex. But let's just call it memory, and that we have it somewhere, and it can be accessed by agents when they need it. Then we have tools. So tools have specific capabilities. They can browse the web, they can store files, they can run code. So like Copilot can run code if you allow it. And then you have chapter completion and everything. So the tools are a significant part of the AI agent, let's say, all build. And last but not least, we have prompts. So prompts actually decide how agents will act and how they will interact mostly with LLMs, which is I think the driver. So the engine is still the power of the LLM that's running behind it. How many of you have used LangChain or Llama Index in the past? Because this is very popular. These are an option, especially for MVPs. Maybe for production, I think they're tricky, but just for trying it out, I think these are interesting options. Then you have some open source libraries which are kind of more powerful in my opinion and better written. So you have AutoGen and PromFlow. These are from Microsoft, and I said they're kind of Azure focused because they do work with most LLMs, but they were designed to mostly work with what's hosted on Azure, right? So that's something to keep in mind. So if your product is already running on Azure, then they're perfect. If it's not as perfect. And yeah, the last one, you have the more open source biased kind of libraries for agents, which are atomic agents and small agents. Now, this is a very small list there. I think there's like hundreds of them, right? But these are some that will do the job and are quite popular. So what about MCP, right? MCP has been the buzzword for the past 4 or 5 months, I think, right? So MCP, or Model Context Protocol, is basically a standard that would make LLMs talk to each other in better terms. And it does come with a lot of advantages. I think it's pretty cool, at least in theory. It's extremely cool how much you could do with MCP, how much you can improve the agentic workflow. So first you have quicker development, better integration, and of course would work better in scale, in theory. And of course the drawback is security. Even though in the description of Model Context Protocol, so if you go to Anthropic's GitHub, they would say security is better with MCP. That's probably not true. Here's how it changes, right? Before, those things would be calling the LLM directly, and now there's MCP in the middle, and no more problems. Well, still problems, but different problems. So yeah, let's go through MCP. So we have MCP components, right? A big component of MCP is the supervisor. So this is the part of the MCP which orchestrates what agents do. So workflows, task distribution, and whatnot. And then we have the classic agent, which does the work, and it should be very narrow to a specific task or function. Then you have the client, which kind of facilitates the communication with the exposed tools and servers. The server exposes everything that's there to be exposed. So this is where the security thing becomes interesting. And then you have, of course, the tools where you have similar to agents. You have this kind of tool set that connects to your databases, to your S3s, to whatnot. Most companies will start training on your data. Like Facebook has started training on your data. Probably OpenAI is training on your data, on your chats. If you use the WhatsApp Llama agent, they will be training on your data. So all you do with all your interactions with these big platforms will be training data, right? And it may be cool for most people, but maybe not. I don't know. It's of course it depends, right? So why Edge AI? So one, you capitalize on existing hardware, right? If you have a good laptop, it can run AI. It can run your AI locally. Data does not need to travel. So even if you have, let's say, use case inside your business, you can still run your AI locally inside your firewall. You would have minimal running costs, right? Basically because when you own the hardware, it's just the watts that you need to pay for. And the last one is, the most important one. It's the only way towards true privacy. And I'm going to show you how easy it is to attain, right? So if you have a good enough laptop, right? It doesn't have to be the best, but if you have a good enough laptop, you can run most models from Hugging Face with a Llama, right? Just clone a Llama and then run it and get any model that fits your hardware, of course, not all of them. But you can run them with a Llama locally and play with it and just use AI on your system. If you have kind of like a new Intel AI PC, you could actually use a thing called Intel AI Playground, which is another super cool project that kind of handles everything from LLMs to image video generation. So it's super interesting, but you do need to have a specific type of hardware for it. And of course, the last one is if you have a Mac. Okay, if you have like a newer Mac, at least M1, then you can run a lot of models using the LMX library. The web GPU movement is growing strong. This is, I think, powered by Google and Hugging Face right now. So if you're using a Chrome-based browser, you can run models on your machine in your browser locally, just pure JavaScript, right? So once you'll have to probably fetch the model from Hugging Face when you're running, let's say, Llama 3.2 on web GPU. That model will get your cache in the browser. Of course, if you clean the cache, you won't have the model anymore, but you get the point. It's super easy, and after that, all the interactions you have with it will be happening locally in your browser, which, in my opinion, is quite amazing. So this is something that it is super easy to use. Of course, you do need to have a pretty decent laptop for it. So if you have a MacBook with M plus processor, it should be fine. Everything works. The last one, but not the least, so this is quite new. I'm not sure if the news hit yet, but 3 days or 4 days ago, this app was released on Android. So it's called Google AI Edge Gallery, and I think it's done in unison with Hugging Face. So basically, you just install this APK, and then you can get models from Hugging Face. Well, models that will fit your phone memory, of course. So if you have a 16 gig phone, then you can run more models. But if you have a new enough phone with 8 gigs, for example, you can run a bunch of models locally on your phone without the data going anywhere else. So I think this is one of the coolest paths that open source AI can go towards. So having this type of AI powers and capabilities and diversity directly on our phones without having to expose any of our personal data. So, I don't know, if you have an iPhone, probably they'll have an app for that soon, but for now, if you have an Android, you can definitely try this, and it's extremely cool.
Speakerii de la Adobe ne-au arătat cum se schimbă DevOps-ul în era GenAI și ce înseamnă MLOps pentru inovația reală. O discuție tehnică și foarte actuală.
We had ML, but we had a classical ML, like a support vector machine, random forest. We didn't have this huge machine learning model that we used to take, like large language model, transformers, vision transformers, autoencoders, table diffusion, and so on. So that's why DevOps was not designed for that. DevOps initially was designed for stateless microservices, CPU-based, with a continuous traffic that are very easy to scale and very easy to auto-scale. In contrast, MLOps is also including projects that are stateful, like training jobs. You have a GPU resources that you need to manage. The traffic is bursty, so it's unpredictable, and it's very, very easy, very hard to scale. And you will see today why and how we can do it. Now, everyone when think about MLOps, think about DevOps plus the model. Of course, the model is the main artifact. It's this huge network of artificial network that you need to keep alive. You need to manage, to build, to deploy, to scale, to rescale, and evaluate. But MLOps is more than the model. MLOps is adding also some extra steps in the CI/CD pipeline. You have some steps or phases in your life cycle for that development that you didn't have in the past. For example, you didn't have on the standard microservices work data collection and validation. You didn't have model training and tuning, evaluation and quality validation, deployment and monitoring is different. And also after the pre-production, you need to retrain your model to detect the drift of your model. So MLOps need to support all of these phases. We picked the GPU because when I think about cloud, if I want to explain what is cloud to someone that is not technical, or even to myself in my mind, cloud is efficient access to resources. And in the classical DevOps world, we have two-dimensional resources. We have the CPU and the memory. Now for ML, we have an extra dimension. We have the GPU. And the GPU is very, very different. It's like moving from a two-dimensional graphic to a three-dimensional world, right? And what is very different with the GPU? First of all, this is the main important key takeaway from this presentation. The fact that, in general, when you buy or rent resources from a cloud, you pay as you go. You have more traffic, you pay for more CPU, for more memory, and you make more money. This is not the case with the GPU. Usually with the GPU you have a fixed budget, and you have a shared pool of GPUs, and your business depends not only on how you use the GPUs, but also on how efficiently you rebalance the GPUs between your applications. So we need an efficient scaling mechanism for GPUs to have the right GPU at the right time for the right job. And for now, that is very difficult to be efficient with GPU. We'll talk about that. Of course, GPU is expensive and it's difficult to be efficient because any mistake can cost a lot of money. But also, because of this bursting workflow, it's very hard to justify like a static pool of GPUs, right? So you need to have a mechanism to actually not have a static pool of GPUs that stay idle for a lot of time. If you want to scale based on a threshold, what do you ask GPUs? How do you know that the GPUs is busy or not? You don't have one metric like you have for CPUs. In GPUs work, depending on your model architecture, on your business workflow, you can monitor the GPU utilization, you can manage the virtual memory utilization, how much time the GPU spends in I/O operation. You have a lot of metrics. And you don't have one unitary metric that you can say, okay, if this metric is high, I need to scale. Or if this metric is low, I want to scale down. So we need two things to recap. We need a mechanism to scale that doesn't ask the GPU anything, that doesn't ask your worker. We need a mechanism that scales without asking the GPU any metrics. And second, we need a mechanism to scale that is also cluster aware, that is able to rebalance these GPUs between clusters. Yeah? So we don't want to ask anything to the GPU, and we want to be cluster aware. So we actually need a mechanism to be able to scale this number of consumers based on how big is the to-do list, or how big is the message queue in front of my service. Yeah? So we need an auto-scaling mechanism, Kubernetes auto-scaling mechanism, that allows you actually to monitor this queue and take decisions based not on the workers. So I don't ask workers, I'm totally apart with the workers, I don't care how much GPU they use. I want to scale only by how much tasks I need to do, how many tasks I have in my day. Luckily for us, we have the second driver, which is Prometheus. Prometheus is like a database for metrics. You can and should publish everything in Prometheus, everything related to your application. Especially you can also publish in Prometheus the size of your queue, right? So in Prometheus you have all this information, and we have a Prometheus rule. Prometheus rule is, for who knows Kubernetes, is a custom definition, is part of the Prometheus operator, and this Prometheus rule, what it's doing is actually constantly querying Prometheus and asking Kubernetes, hey Kubernetes, how many messages are in this queue? And Prometheus rule is publishing this value as a number in our cluster. Then we have the standard auto-scaling mechanism that instead of saying, okay, how much CPU and memory did you use, it's just asking Prometheus, hey Prometheus, what is the size of the queue? And this queue-based HBA is actually scaling based on this metric. And you put here the expression that you want to query Prometheus, and the name of the metric that you want to expose. Then in your horizontal code auto-scalable, just say, hey, I want to scale based on this metric, and I want to query this metric using this argument. Like, for example, the name of the...
Ultima prezentare pe care am selectat-o pentru voi este o reflecție sinceră asupra viitorului software development-ului în era AI, ce se schimbă și ce rămâne esențial.
Everyone who's working in digital probably had that experience. And I really want you to ask that question to yourself. Why is that still happening today? It's 2025, we have AI, we have a lot of tools that can help us in creating those prototypes, not even a full product, just that prototype, just to prove that it's something that can work. And I want you to remember this after the talk, because then I hope that you have some tools to think about differently, so that you think, okay, if I'm going to create a prototype, I'm going to do it completely different. AI wave, of course, it has two things. You have, on the one hand, indeed, new features that are possible with AI, and those are very important, and I really want you to focus on that and incorporate them into your products. But on the other hand, there's also the other part of AI, where AI can really help you, assist you in building the products that you're creating. And it can do so in very different ways, not only in coding, but you also have to think broader than that, and even though we're all engineers or other roles connected to engineering, because this is DevTalks, I don't want you to limit yourself to, I'm an engineer, I just write code. I really want you to broaden up and think about, okay, but if I'm going to create an AI product, maybe I have to change my mindset a little bit about what engineering is, because this is what will be changing in a couple of years. Good digital products still mean the same as it did 5 years ago. It's not because AI is here that a digital product, a good digital product, is completely different now. You still want a good user interface. You still want it to be smooth, to be easy to work with, to be stable. All those things, they are still true today, even in an AI world. So that doesn't change. On the other hand, what is changing, and that's the important one, I think, that's how we are working. If you look at it, the promise of AI, it also made the triangle that you typically see about speed, quality, and cost. Normally, your project manager will say you can only pick 2 because otherwise your product will go to shit. You can only sell it 2, and you can only do that. Well, basically, with AI, it's no longer true. We really can build products quicker with a smaller team and without sacrificing on that quality. And that's really important because over the years, that was really impossible to do, but now with AI, it's such a big change that it will really feel like we can do this really. AI will come in your products either way. Whatever happens, in some way there will be a feature, there will be something that you will incorporate in your product that will be AI related. No, I really want you to think about what is the problem that I want to solve for my client. Very obvious, but it's very difficult to get there. And that's why we really need to understand our client better, and also AI can help us with that. You can just start with using tools that are already available. Things like Notebook LM, I use it on a daily basis. Just input all the information that you have, input what you want to know, ask the questions that you would normally ask for the clients if you would see them directly, and it can really assist you in, it can really be an assistant for you during that process of qualifying or if you're going to do an RFP, for example. Another tool that we often use is DeepSeek. If it's on OpenAI with ChatGPT or with GenAI, it doesn't really matter. All those tools are kind of similar. What tool is better than one thing or the other in another. But a deep research feature of those tools is actually a very interesting one to get some more in-depth knowledge about a client who's asking you something, and maybe you're not an expert in the sector of the client, but if you have a deep research question that you ask, tell me something more about the client. I'm going in a meeting where I have this profile, for example. This front can already give you a lot more information about that client that you're going to work with. Tools like Conveo that we're using, and that's not the only tool, there are other tools that you can research. But with tools like this, it can really speed up that process to bring all that time down to doing research only means doing 4 hours of work anymore for us. So it really means going down from 3 to 4 days of work to 3 to 4 hours of work, where you have the same result at the end, still knowing, understanding your customer in the same way, just with a lot less time to do this. Tools like Dust and Onyx actually can help you with that, with exploring better your knowledge bases, knowing what have we already done in our company with tools like X or Y. Also, if you have to create a presentation, what's the engineering vision of in the pocket? How are we presenting the ITP way, for example? This presentation is also the result of what is the knowledge that we already have, what are the slides that we already have, can we bring them together in one coherent story? These kind of tools can really help you with that. One example that I also wanted to give, you don't always need a complete fancy tool set to do that, but one of my colleagues, for example, what he created was a tool where he just connected a couple of things from a Todoist task manager. He connected that with Google Drive, where he kept all his notes, for example, that he's creating in Obsidian, and he connected them with Gemini. And maybe you think, okay, why would you do that? Maybe it can be interesting, but the result of that for him is actually that he can prepare his meetings, his recurring meetings that he has on his agenda, where he has to-dos written down. He can use it to prepare his meetings. So if he has a regular weekly one-on-one with somebody, he can just ask his AI, okay, I have a meeting with Kati, for example, my colleague. What should we be talking about this week? What did I forget about that? And it really helps him to be more efficient in his job as well. And it doesn't really cost you money. It just costs you some creativity of connecting the things that are already there. And that's already possible in a very cheap way as well. So don't only look towards the more expensive tools, also look towards this kind of tools. We are using Cursor a lot in our company. I think every developer has it on his PC now and is actually using it. And it really speeds up the development by 20 to 30% already today. And we're still exploring how are we going to use this, because it's kind of gimmicky at the start when you start fiddling around with it. But once you get the gist of it, and once you have some rules set up, making sure that your consistency is right, that you give it a set of default examples of this is how we do a React Native application here in the pocket, for example. If Cursor can learn that, and if you give it the right input, if you give it the right feedback, it can really become a very powerful tool. And I'm not vouching for Cursor, other tools like Copilot, for example, they can do the same. But the thing is, you and your team, you should really start exploring how can we embrace that technology and how can we learn how it reacts, how we need to give it feedback. Because otherwise, as long as you don't give it the right feedback, it won't learn from what you want to do. A lot of tools that you can use there. You can look into AI reviews. There are a couple of companies already working on that, like CodeRabbit, who's really working on merge requests, how we do that, how we give feedback, give automated feedback. You have companies like Aikido, who's working on security, to give feedback on that. So a lot of opportunities there as well. The tools, for example, that we use there as well is N8N, which is basically not an AI tool, it's a workflow automation tool that we just use to connect a lot of the steps in our build process, but also in our just way of working process, because not everything is code, but just to click everything together and react on things that are happening. What's not going to change is this. Those 7 principles will actually give you a way to think about everything in digital, to make sure that you think about it in the right way, that you are sure that if you follow these principles, that you can actually create better products, bigger futures for your clients, and that's what we are doing at the company. Thanks for your attention.
Sper că ți-au plăcut ideile din acest video și că ai găsit inspirație pentru proiectele tale. Dă un like dacă ți-a plăcut, abonează-te pentru mai multe noutăți din tech și lasă-mi un comentariu cu ce subiect ți s-a părut cel mai interesant.